With this video, we begin to address evaluating limits algebraically. And we saw that the very first way that we attempt to evaluate each limit algebraically is using direct substitution. And that means that we're going to take the limit as the limiting value of x, and we're just going to plug that into the expression, and if we get a value back, then direct substitution worked. So for example, in number 5, we have the limit as x approaches 2 of x cubed. That would just be 2 to the third, which is 8. The second one, limit as x approaches 0, we plug in 0 for x. That's 0 minus 1, which is negative 1. And we get the limit as negative 1. The limit as x approaches negative 3 of x squared plus 3x, as long as we can plug in x squared, that's going to give us 9. 3x is going to give us negative 9, so a limiting value of 0, or rather a limit of 0. Next, limit as x approaches negative 3 of 2x squared plus 4x plus 1. We plug in negative 3. That's 2 times 9 minus 12 plus 1. Sorry, that's 2 times 9, which is 18, minus 12, which is positive 6, plus 1 is 7. Number 13, limit as x approaches 3 of square root of x plus 1. As long as we can plug in 3, we get square root of 4, which is 2. Number 15, limit as x approaches negative 4 of x plus 3, quantity squared. Plug in negative 4, we're going to get negative 1, quantity squared, which is 1. As long as this works and doesn't give us back an undefined value, then direct substitution is all we need to evaluate the limits. Limit as x approaches 2 of 1 over x, that's just 1/2. Limit as x approaches 1 of x over x squared plus 4, we get 1 over 5. Limit as x approaches 7 of 3x over the square root of x plus 2. 3x is going to be 21. Square root of 7 plus 2, square root of 9 is 3. So that's 21 over 3, or 7. So that's how we apply the direct substitution method to evaluate limits algebraically. It's nothing more than evaluating the function at the limiting value. And if that works, that's all you have to do. As long as we don't get back an undefined value, then that's all that's necessary. Okay, I'll go on to 23 through 26. In this next set of problems, we're given two functions, f of x and g of x, and we want to apply various limits, or we want to evaluate various limits. Now with these, we do have an issue of function composition. And the way we evaluate limits of function composition is a little bit different than might be expected. So I want to point this out. So we'll say the limit as x approaches a, any constant value, of f of g of x, some kind of function composition. The way we'll do that is we'll take the limit of the inside function. Then once we find that limit, we'll plug that value into the outside function. We won't take the limit of the outside function. We only take the limit of the inside function, find that value, plug it into the outside function. So number 23, limit as x approaches 1 of f of x, that's simply 4. Limit as x approaches 4 of g of x, that would be 4 to the third, which is 64. Now the limit of g of f of x, remember we take the limit of the inside, so we want the limit as x approaches 1 of f of x, and that's 4. And then we're just going to take that value and plug it into the outside function, and g of 4 is 64. So they kind of step you through those values there. Number 25. We have f of x is 4 minus x squared, g of x is square root of x plus 1. We're looking for the limit as x approaches 1 of f of x, and so that's 3. Next, it asks for the limit as x approaches 3 of g of x. That would be 3 plus 1 is 4, square root of 4 is 2. Finally, we're asked for the limit as x approaches 1 of g of f of x. And here I'll actually write it out. We're looking for the limit as x approaches 1 of f of x. We're going to find that limit and plug it into g. We don't take the limit of g. So the limit as x approaches 1 of f of x is 3. We take that value and plug it into g, so we're looking for g of 3, and we've already found that that's 2. And so this is how limits work with function composition. We'll go on to number 27 in the next video.